Today we're going to again be in section 5.1 and we're on the third day of verifying identities. So for our first example, we have cosine of x all over 1 plus sine of x. This is equal to 1 minus sine of x all over cosine of x. So I'm doing this problem to kind of introduce a new strategy that we're going to use. And that is called multiplying by the conjugate. The conjugate is when you have a binomial, and a binomial means you have two terms, and what changes is the sign. So we're going to work with the left side, and if I want to introduce this idea of a conjugate, I need to look at the right-hand side and look at what binomial I have. So notice on the right-hand side, we have this binomial of 1 minus sine of x. So I'm going to introduce that term to the left-hand side. And what I mean by introduce it, I'm going to multiply the top and the bottom by 1 minus sine of x. So I'm going to take this cosine of x all over 1 plus sine of x, and I'm going to multiply by 1 minus sine of x, top and bottom. Now, it's important that you put the bottom with parentheses there because we're going to be distributing that in. The top I'm going to leave as is. So I'll have cosine of x times this quantity of 1 minus sine of x in the numerator. So my denominator, I have a binomial times a binomial, so I have to FOIL. For those of you who do the box method, this is where you would do the box method. So if I do my first outer inner last, or double distributing, whatever you call it, 1 times 1, let me get a different marker to connect them. So I'm going to do my 1 times 1, then my 1 times negative sine of x times the 1, and sine times the negative sine. So 1 times 1 will give me 1. 1 times negative sine of x will give me negative sine of x. Positive sine times 1 will be plus sine of x. And then this positive sine times the negative sine will be negative sine squared of x. And now I need to see if I can combine any terms. In the denominator, notice I have a negative sign and then a positive sign. So they're actually going to cancel out. So I have cosine of x times this 1 minus sine of x. And in the denominator, I have 1 minus sine squared of x. And again, you always want to be mindful of what you're trying to prove. So when I look at the right-hand side, notice I have a cosine in the bottom, and I don't have that yet. I have a 1 minus sine squared. But I know I can use the Pythagorean identities and replace this 1 minus sine squared with the cosine squared. So I'm going to come up here so I have some more room. So you still will have cosine of x times 1 minus sine of x. And in the denominator, again, I can replace 1 minus sine squared with cosine squared of x. And now I want to see what I can reduce. So notice I have a cosine in the top and a cosine squared in the bottom. A cosine squared is made up of two cosines. This essentially is a cosine times a cosine. So the cosine in the top is going to cancel out the squared in the bottom. So I'm still going to be left with a cosine in the bottom. So now I'm at 1 minus sine of x all over cosine of x. And notice that that is what we were trying to prove. So I have now verified my identity. So typically, when you look at these problems and everything is already in terms of sine and cosine, and I can't really split my fraction up in any shape, way, or form, that's when you want to go this whole idea of the conjugate route. Not saying that it will work for every single problem, but it is a different method. So for our next example, we have cosecant squared of theta all over cotangent of theta. And this is equal to cosecant theta times secant theta. So in last night's video, I showed you two different ways to go about the same problem. Again, there's multiple ways to go about this problem. However, I do want to highlight to you some strategy. So if you thought you could use the Pythagorean identity, the issue with that is if I use the Pythagorean identity, which says 1 plus cotangent squared equals cosecant squared, I would be introducing a plus sign. So let me just write that down just to kind of show you what I mean. So if I replace this top with 1 plus cotangent squared of theta all over cotangent of theta, notice I've introduced a plus sign, and I don't see any plus sign on the right-hand side. So as far as strategy-wise goes, that would not be the best strategy for this problem because there's no plus sign over there. So that would not be the best way to go about this problem. So let's talk about our different methods that we can do. So the next method that we go back to is our basic one, and that's get everything in terms of sine and cosine. So I know cosecant is 1 over sine. So cosecant squared is 1 over a sine squared of theta. And in the denominator, I know cotangent is cosine of theta over sine of theta. And notice I made this fraction bar a little bit bigger so you can clearly see your fraction over fraction. So we go back to our basics of keep, change, flip. So I have 1 over sine squared of theta, and I'm multiplying by the reciprocal of sine of theta over cosine of theta. And similar to the last problem, notice when I'm multiplying, I have a sine in the top and a sine squared in the bottom. So I can kind of reduce this by a sine. So this sine is going to cancel out with that squared. So that means I'm at 1 over sine of theta times a cosine theta. And again, I could have multiplied them together at this step right here, and I would have had sine of theta over sine squared cosine. I just kind of reduced it before I put it together as one fraction. And now we want to kind of think about splitting my fractions apart. So I know that multiplication, you don't need common denominators. Multiplication is just you multiply your tops and your bottoms. So I can split this up and say 1 over sine of theta times 1 over cosine of theta. And I know 1 over sine of theta is cosecant of theta. Oops. And I know that 1 over cosine is secant of theta. And notice we have now verified our identity because we got the same thing. All right, so one more example. So this is our last example for today. So I have sine of theta over tangent of theta plus cosine theta over cotangent theta. And I'm trying to prove that this is equal to sine of theta plus cosine theta. So I want you to notice that I have plus signs in play. So as far as, again, strategy, you want to look at your signs. So both sides of the equal sign have a plus sign involved, so I don't need to mess with that. What I do need to do is get rid of this tangent and cotangent somehow. So I'm going to show you again, I'll show you one way, and then tomorrow in class we're going to discuss a different way to go about this problem. So if we go back to our basics of getting everything in terms of sine and cosine, I have sine of theta all over sine of theta cosine theta plus cosine theta all over cosine theta over sine of theta. And we know that whole idea of keep, change, flip. One thing I do want to show you is that the signs are not going to cancel right here and being left with 1 over cosine, because technically this is a sine over a 1. This is like a cosine over a 1. So I have sine of theta times cosine theta over sine of theta. And then over here, I have a cosine of theta times sine of theta over cosine theta. And now I need to do some cleaning up, so I can tell that the sines are going to cancel here and the cosines are going to cancel there. So now I have cosine of theta plus a sine of theta. And addition is commutative, so that does not matter which one I put first. So cosine of theta plus sine of theta is the same thing as saying sine of theta plus cosine of theta. So we have now verified the identity. Again, tomorrow in class we're going to talk about a different way to prove this same problem. But that's all for today.